So, dear participants, so welcome to the 44th session of day 5, Wadla 3.0 on topic recent trends in deep learning and applications. So, today we have with us Dr. Sriparna Saha, Associate Professor, IIT Patna. So, she is going to talk about multi-modal information processing application to NLP. So, before starting her talk, so I would like to introduce her. So, Madam has received the MTech and PhD degree in the computer science from ISI Kolkata in 2005 and 2011, respectively. She is currently an associate professor in the Department of Computer Science and Engineering, IIT Patna. She is author of a book published by Springer Verlag. So, she has authored or co-authored more than 400 papers. Her research interests include multimodal information processing, natural language processing, machine learning, information extraction, text mining, bioinformatics, and multimodal optimization. Her H index is 38, and total citation count for her paper is 7,546, according to the Google Scholar. She is also a fellow of IETE and a senior member of IEEE. She is the recipient of the LT Rasi Roy Memorial Gold Medal from the ISI for outstanding performance in MTech. So she is the recipient of Google India Women in Engineering Award 2008, Nasi Young Scientist Platinum Jubilee Award 2016, Bird Award 2016, IEI Young Engineering Award 2016, SERB Women in Excellence Award 2018, SERB Early Career Research Award 2018. So now I would request Sriparna Madam to take over this session.
Yeah, many thanks, Rakesh, for this invitation. And yes, so today I'll be talking about multimodal information processing, and there are some of the applications in NLP, some recent NLP applications. So yeah, so first of all, I will introduce like what do we mean by multimodal information processing, and like what do we mean by multimodality, what is a multimodal information processing, and then I will show you some of the applications in natural language processing. So if you see that our experience of the world is basically multimodal, because when there is an object, we used to see the object, we used to hear the sound of the object, feel the texture of the object, smell the odors of the object, taste the flavors of the object, and then we come to a decision. Like whenever there is an object, we are using our multiple sensors, we are collecting information using the multiple sensors, and then we are consolidating the decisions, consolidating the information collected from multiple sensors, and then we come up to a decision. So, the multimodal information processing basically means that we are consolidating the heterogeneous data coming from various sensors and data inputs into a single model. So, we are collecting information from multiple sensors, then we are combining them, and that information we are passing through a single model for decision making. So the approach of training models on only single source of information such as either text, audio, or video is commonplace. There are many models where we are only considering a single source of information, like only the text data or the audio data or the video data. But there are very few models where which incorporate the multiple sources of information, like text plus image or text plus audio or audio plus video. So there are very few models where the multimodal information is at the input. So multimodal information processing means that now we are not relying on a single source of data, we are relying on the multiple sources of information. So like here you can see some applications of multimodal information processing. On the left hand side, you can see the application of emotional recognition. So like you have to detect the emotion of a particular person. Like suppose a speaker is speaking, you have to detect the actual emotion of the particular speaker. So what is the actual emotion of the speaker? So you know that the when the speaker is speaking, you know that we can not only see what the speaker is speaking, but you know that we have the speaker's audio tones, or the the visual, the facial expressions, and also facial expressions, the audio tones. So there are many, there are multimodal information, and after considering all these multimodal information, we can decide what is the actual emotion of the particular person. Like from the facial expression, from the body language, from the audio tone, and also from the textual description of the speaker, we can easily understand what is the actual emotion of the particular person. So like for example, there are two speakers, Joey and the Chandler, and we can always consider the audio, video, and the textual description, and by combining all these descriptions we can easily decide the actual the emotion of the particular person. So on the right hand side you can see that this is an example of from the Twitter domain. So from the Twitter domain, suppose we are collecting several tweets, and now we are classifying the tweets into informative and the non-informative. So you know that suppose when we are collecting the social media tweets, you know that tweets are of two types, informative and the non-informative. So and then what we are doing is that for all the informative tweets can be summarized, and we can get a summary, and that summary can be given to the rescue team. Like this kind of summary is very useful for the disaster situation. Suppose there is a disaster, and during the disaster situation, so people used to stay connected with each other using the social media platform. So they used to update their status in the social media. So now we can collect the data from the social media, we can collect all the tweets from the social media. And nowadays people are writing the multimodal contents in the social media. They are uploading the not only writing the textual tweets, but also the images in the tweet. So we can collect the multimodal tweets, and then we can easily categorize the tweets into two categories, informative and the non-informative. So the informative means that that tweet is important for generating the summary, and the non-informative means that tweet is not important for generating the summary. And all the informative tweets can be combined together, can be summarized together, and then that summary can be sent to the rescue team, and the rescue team can plan for the rescue operation, and the rescue operation can be started. So here also this is an application of the multimodality, where not only the tweet text but tweet image is also considered for categorizing the tweet into informative and the non-informative. So basically, that what is the benefit of multimodality? Because now we are collecting information from multiple sources. So you know that we are not using you are not using the only one sensor, but we are using multiple sensors. And as a result, if suppose there is any wrong information captured by a single sensor, that can be rectified by the other sensors. So and also in many cases these modalities could be complementary in nature, or the modalities could be supplementary in nature. So for example, text and the image are sometimes complementary to each other. So for example, that if you see like that there are many abstract concepts like love, affection, which can be better described using text but not using images. But there are some concepts like how a piano looks like, or how a how a particular animal looks like. These concepts can be better described using image but not using text. So image and text are somehow complementary to each other, and that way we can easily utilize multiple modalities to better capture some better information. So how multimodal learning works? So basically here we need at least two information sources, and for each information source we should have a information processing module. and now we are collecting some features from each information source. Then we can concatenate all the feature vectors, and then that concatenated feature vector can be passed through some classification layer or the regression layer, and accordingly the classification or the regression can be done. So either we can solve some classification task or some regression task. So yeah, this is the in general how the multimodal learning basically works. So we are having multiple sensors, and we are collecting the information from multiple sensors. We are combining the feature vectors. We are passing this feature vector through some classification of the regression layers, and then the the learning is basically done. So now coming towards the fusion, because now we are extracting features from multiple modalities, like we are extracting features from different modalities. For example, in case of this categorization of the informative and non-informative, there are two modalities, text and the image. So we are extracting some features from the text, some features from the images. Then we are combining them together. So now this fusion can be done at different levels. So either we can have a early fusion, or we can have a late fusion, or we can also have an intermediate fusion. So you know that talking about the early fusion, so you can see here that early fusion means that suppose there are multiple sensors or the multiple sources, and we are extracting some feature vectors from these different sources. And now we get some feature vectors from different sources. And now basically what we can do is that we can simply combine these, we can simply fuse the feature vectors. So here we can also apply different techniques like attentions, etc. So attention basically helps in putting emphasis on a part of the input based on the other modality. Like suppose we have the text modality, we have the image modality, we have the audio modality. Now based on the text modality, we can put emphasis on a part of the image, or based on the audio modality, we can put emphasis on a part of the text. So that is done in case of this in the attention vector, and that is basically called the early fusion. So we are extracting some feature vectors from the individual sensors, and then we are concatenating the feature vectors, and now there is a weightage assigned to each vector depending on the other modality. So the but here the assumption is that all these sensors are independent. All the sensors are having independence. There is no relationship, and there is a sync between all the sensors. Like for example, if you have a YouTube video, so you for each timestamp you have the text, you have the audio, you also have the video. So yeah, that is the only assumption. So disadvantage of early stage data fusion is that a large amount of data will be deducted from the modalities to make a common ground before fusion, and we need to synchronize the timestamp of the different modalities. Now we can also have the late fusion. So in the late fusion, from the name itself, we can understand that here we are not fusing the feature vectors, okay, but rather we are simply applying the voting, okay, voting of the decisions of the models. So here this is a kind slightly different. So what we are doing is that we are extracting some feature vectors from different sensors. Then those feature vectors are passed through some models, and the models are taking some decisions, and now there is a voting mechanism applied on the decisions. So like for example, model 1 is taking a decision, a class level decision. Model 2 is taking a class level decision. Model K is also taking a class level decision. And now there is a data level fusion. So you are applying some majority voting or the weighted voting, and that is the decision level fusion. And then that is the basically output. So this is called the late fusion or the decision level fusion. So late fusion process modality is independently followed by fusion at a decision making stage. This is beneficial when the modalities are significantly varied from each other in terms of sampling rate, data dimensionality, and the unit of measurement. So late fusion often gives better performance because errors from multiple models are dealt with independently. Thus, errors are uncorrelated. Now there is also intermediate fusion. So the intermediate fusion means that, that suppose we are having three multiple sensors. So at a time we are combining two sensors, okay, and then the output of this is combined with the third sensor. So intermediate fusion is in a deep learning multimodal context is a fusion of different modalities representations into a single hidden layer. So what we are doing is that we are combining the, the two sensors features, and then that is further combined with the third sensor. So in a hierarchical fashion, in a tree-like fashion, the fusion is done. So different modalities can be fused simultaneously into a single shared representation layer, or this can be performed gradually using one or multiple modalities at a time. So in a hierarchical fashion, we are fusing. So first we are fusing sensor 1 with sensor 2, then that is fused with sensor 3. So in a gradual fashion, in a hierarchical way, we are fusing the the feature vectors. So now so this is the somehow the basics of if you can see, this is somehow the basic of multimodal information processing. So now I will show you some of the applications of this multimodal information processing in NLP domain. Okay, so because multimodal information processing is heavily used in natural language processing. So I will showcase now some of the applications of the multimodal information processing in NLP domain. So you know that one such application is in the dialogue systems. So the dialogue systems are nowadays very popularly used because most of us on a daily life we are using Alexa or Siri. In our day-to-day life we are using Alexa or Siri, and Alexa and Siri are some question answering bots. So we are asking some question to Alexa, and Alexa is giving some answer. In our mobile phones also we have the Siri. So this way, chatbots are nowadays very popularly used. And if you see, this is the overall architecture of a chatbot, and the chatbot is having many components. Like when the customer is saying which restaurant can I book for two people for today, this is the user input. So first, the user input is basically analyzed. So which restaurant can I book for two people for today? So this is the user input. So the user input is first analyzed. The first module is basically called the natural language understanding module, or the NLU module. So the task of the NLU module is to understand the user's input. So what the user is trying to say. So for example, dialogue act classification means what is the type of the user's input. So for example, it is a question. So user is asking a question. So the dialogue act classification will determine that this is a question. And then the intent classification means that what is the user's intent. For example, user wants to book a restaurant, so the intent is booking a restaurant. So the intent is the booking a restaurant. And the slot means to identify some important information from the user's utterance. For example, the important information are two people and the today. These are the important information. So these are the two important slots from the user's utterance. The natural language understanding module is trying to identify all this information from the user's input, and that is represented as a state to the dialogue manager. So now the state is basically that this is a request, intent is booking a restaurant, and the slots are two people and today, and that is given as a state to the dialogue manager, and the dialogue manager basically maps the state into action. So given this particular user's input, what will be the action of the chatbot. So the chatbot will basically generate, will ask some question to the user. So what will be the next question by the chatbot? So basically, the chatbot will ask the next question. What is the it will ask regarding the category of the restaurant. So the action is basically the asking the category of the restaurant. So next is the natural language generation module. So this natural language generation module will convert the action into system response. So the system response would be that, can you kindly suggest what will be the, do you have any preference on the category of the restaurant? So this is the overall dialogue system. That yeah, the first block is the natural language understanding module, which will try to understand the user's utterance better. Then there is a dialogue manager, which will try to which will take the state and it will try to map the state into action. And the dialogue natural language generation will try to basically translate the action into system response. So this is the overall dialogue system. So now I will show you that in many of these components, if we can use the multimodality, it will be helpful. So, the dialogue act classification means that to identify the communicative intention of the speaker in a dialogue conversation, classified into a predefined category. So, that the first task of the natural language understanding is the dialogue act classification. So, dialogue act classification means to identify the what the user is trying to say, whether user is asking a question or user is giving a command or a user is simply making a statement, or what is the user's basically communicative intention. So that is called the dialogue act classification. So, like for example, what kind of experience do you have deal with the child care? So this is a question. I think it is really, this is a statement. How about you? This is a open question. That's all right. This is an understanding. So these are the different types of dialogue acts. So if you see the literature, so primarily all the works in the dialogue act classification are mostly, they are textual based. So they only consider the textual description of the utterance. They do not see the non-verbal features like, the speaker's tone or the facial expressions, etc. But the speaker's audio tone or the facial expressions are also important, because by considering the audio tone or the facial expressions, we can better understand the emotional state of the speaker, and we can better understand the communicative intention of the speaker. For example, if you see the okay, sure, or yeah, right, these utterances. So these utterances, that can be agreement or a disagreement. So okay, sure can be either said agree, in a agree, either can be maybe considered as agreement or a disagreement if implied sarcastically. So that mostly in expressive DAs such as greeting, thanking, apologizing, etc., there will be some disambiguity. Sometimes those could be sarcastically said, or there will be some those could be agreement as well. So if we can consider the users, the speakers non-verbal features like the change of tone or the facial expressions, we can better understand the communicative intention of the speaker. So we proposed an attention-based, multitask, multimodal, deep neural network-based approach. So here we have considered three modalities: audio, video, and the text. So when we started doing research in this particular field, we identified that there is no existing data set. So we also created a new data set, which is called the multimodal emotion DA, okay, which is called the EMOTIDA, because as the new dataset was available and we want to develop a supervised model, so we need to have a training data. So our first task was to create a training data. So manually created such a data set, which is called the EMOTIDA. So here, each utterance is having three modalities: audio, video, and the text. And also we identified that dialogue act classification is having some associated tasks, like there are some correlated tasks. Like if we can better identify the speaker's emotion or the sentiment, like if for example, if the speaker's sentiment is positive and emotion is also happy, then mostly the utterances are agreement type. or but if the user is angry and the sentiment is also negative, then the utterances are of disagreement type. So you know that emotional recognition and the sentiment classification are considered as some auxiliary task, and our primary task is the dialogue act classification. So what we did is that with the help of the auxiliary task, we tried to improve the accuracy of the primary task, that is the dialogue act classification. So we solved this in a multitask framework where our primary task is the dialogue act classification and our auxiliary tasks are emotion recognition and the sentiment analysis. So basically, we scanned the literature for the existing data sets. We zeroed down to IMOCAM and the mail, and you know that these data sets are not annotated for the corresponding dialogue acts. So you know in the dialogue act classification there are 42 tags, but 12 tags are most popularly used. So these 12 tags are greeting, question, answer, statement, opinion, statement, non-opinion, apology, comment, agreement, disagreement, acknowledge, back channel, and the others. And with these 12 tags, what we did is that we identified IMOCAP and the mailed as the data sets. We combined these two data sets. These two data sets are multimodal emotion recognition data sets. So already these data sets are annotated with the emotion tags. So we manually annotated these two data sets with the 12 these chosen tags. So finally, our data set is named as the Emotida. So this Emotida is having 1341 dyadic and the multi-party conversations. There are 19,365 utterances. And as I mentioned earlier, that each utterance is having, three modalities: audio, video, and the text. And here you can see like some examples. Adders don't snap, they stink. So dialogue act is the disagreement, but the emotion is the anger. Well, I just checked our messages and Jesua did not call. This here the dialogue act is a statement, emotion is sad. That's very amusing indeed. Here the dialogue act is a disagreement, but the emotion is anger. Come on, pick up, pick up. Here the dialogue act is the command, emotion is fear. So these are the some examples of the emotive data set. So this is the distribution. So 48% samples are from the IMOCAP class, and 52% samples are coming from the male class. And this is the distribution of the speaker distribution. Also, you can see that how the speakers are distributed. So you can see the qualitative aspects of the emotida. But suppose Monica is saying, I can't leave it, you caused a hole in my dingy floor. So here, if the dialogue act is a disagreement, and if you know that the emotion is anger, so you can easily understand that the appropriate dialogue act could be disagreement. Then, if suppose the utterance is, well, I appreciate you coming over and talking to me. I mean, it definitely helps. Here, if you know the emotion is sad, then the dialogue act will be acknowledged. Okay, so these are the qualitative aspects of the emotida. So the presence of emotion in the data set caters the models with the ability to use additional information while reasoning about the dialogue act. So you know that here also you can see that suppose when you are considering the multimodal information, so Foiba is saying fine, then you tell Roger because he was really looking forward to this. So if the text is suggesting agreement or the opinion, and the audio is suggesting commending tone, and the video is suggesting furious. So after considering all the modalities, you can easily understand that the actual dialogue act tag is basically comment, because though the text is suggesting agreement or the opinion, but the audio, by after considering the audio and the video, they are in opposite with the text. So you can easily understand that it is a comment, it is of comment type. Then that's very amusing indeed. So here you can see the text is of agreement type, and the audio is sarcastic tone, video is slight anger. So the actual DA tag is basically disagreement, because though the text is agreement, but the audio and the video are completely different from the text. So the actual DA tag is basically disagreement. So the availability of complementary information across the multiple modalities improves the model's ability to learn discriminatory patterns that are responsible for this complex process. So that is the, the emotida that, that what happens is that, when you are using the multimodal information, that is, somehow helping us to correctly predict the dialogue act tag. So finally, this is our proposed methodology. So you can see that what we are doing is this is a model, somehow a complicated model, deep learning based model, but it is a deep learning based multitask model. So as there are three modalities: audio, text, and the video. So what we are doing is that we are extracting some features from text, some features from audio, some features from the video, and then those features are concatenated, and then we are passing these concatenated features from some different attention layers, and finally these attendant feature vectors are passed through some classification layers, and there are two channels, one for the dialogue classification, another for the emotion recognition, and we are calculating the errors, and then errors are combined and finally back propagated. So errors computed from each of these channels are backpropagated jointly to successive prior layers of the model to learn joint features of both the tasks.
You can't say something if she is eating.
Yeah, any question?
No, no.
Ma'am, I have one question.
Yeah, please. Yes.
Ma'am, I just want to ask that in data fusion, is there any other technique other than the voting technique?
Other than the no,
Voting technique.
yes, there are many other techniques available. Like for example, I told you regarding the attention. So either you can go for the attention based techniques, or you can simply concatenate the feature vectors, or you can have this kind of different types of attentions, like that you can read our paper, this paper you can read. So in this paper we have introduced different types of attentions. So we have the intermodal attention, intertask attention. So there are different types of attention vectors that we have used. Okay, so you can use different types of attentions.
Okay, thank you, ma'am.
So,
Yeah, any question, any other question?
Nothing, ma'am. You can continue, please.
Yeah, okay. So we have shown results on different setup. You can see, like we have done an ablation study. We have compared only with the text modality, with the audio modality, with the video modality. Then when we are combining the two modalities together, like text plus audio, audio plus video, text plus video, and all the three modalities. And also, as our dataset is having some dyadic conversations and some multi-party conversations, then what is happening? So like you can see that when we are solving two tasks together, so there is this improvement, like both the two tasks are really helpful. Like like emotion recognition is helping the dialogue act classification. So you can see that there is an improvement in the F1 score. So yeah, so basically multitasking framework performs consistently well compared to the single task DSC variant. Different modalities improve the unimodal DSC baseline significantly. So yeah, so these are some ablation studies. Here we have shown the importance of different attention mechanisms: intermodal attentions, intertask attention, self attention. So we have different attention mechanisms, and we have shown the results with different attention mechanisms. So yeah, so this is another case study that we have done. So now, we have also done some experiments with the tweet tag classification. So I was just discussing about the dialogue act classification. So dialogue act classification means to understand the communicative intention of a particular speaker. Similarly, the tweet tag classification means to understand the communicative intention behind a tweet. So when someone is making a tweet, what is the communicative intention behind that? So speech act classification helps in determining the communicative intention of a speaker. So suppose you are making a person is posting a tweet. So what is the intention behind the particular tweet? So that is basically called the tweet act classification. So like, my dream is to have my boat returned to me. Rasat said, I have been wishing to die every second after my boat died. So this is an example of an expression. Like, you should direct just a little bit of your criticism towards the role the Israeli played. So this is an example of a suggestion. Why the La Guin title in the gallery? This is an example of a question. So this way you can see that these are the different types of tweet tags. So primarily all the works in the tweet tag classification limit themselves to utilize only the textual modality. But sometimes tweets are also having some emojis. And if we can also consider the emoji, we can better understand the the tweet the communicative intention of the particular person. So the emoji and the text together can help us in better understanding the communicative intention. So, and also if we can understand the speaker's emotional state and the sentiment, they can also help us in understanding the communicative intention better. So like in the tweet acts like expression, request, threat, etc., Twitter sentiment and emotion can help in recognizing the communicative intention. So basically here also we have solved the task tweet tag classification in a multitask setup. So tweet tag classification is our primary task, and the emotion recognition and the sentiment analysis are our auxiliary task. And we curated a data set called the EMO-TA. So this EMO-TA is basically the emotion aware Twitter classification. So this data set is completely new. Again, when we started doing research in this particular area, there was no such data set available. But we really want to develop a supervised model. So it was very difficult for us to do research in this area. So we created our own data set. So we have established that somehow multimodality is helpful, like emoji is helping in understanding the tweet tags better, and also the multitasking is helpful, like the emotion and the sentiment are helping in tweet tag classification. So that we started searching for some suitable data set, and we zeroed down to Semable 2018 data set. And but this data set is suitable for the sentiment emotion recognition. So this data set is already annotated with the multi-level emotions, but this data set is not annotated with the sentiment and the tweet tag tags. So we used 7 tweet tag tags, which are statement, expression, question, request, suggestion, thread, and the others. And we identified 6810 tweets to create this EMO-TA dataset. And then we manually, annotated each of the samples with seven of these tweet tag tags. And for the sentiment annotation, we have used the IBM Watson sentiment classifier, and each of the tweets is classified into 3 categories: positive, negative, or the neutral. And also that the data set is already annotated because we are using the Sriparna 2018 data set. So data set is already annotated with the 11 multi-level emotion categories. So finally our data set is having 6810 tweets, and each tweet is having, you can see the tweet tag category, emotion tags, and the sentiment tags. So tweet tag tags we have manually curated. Emotion tags were already present with the data set because we are using the single data set. And the sentiment tags we have added with the help of the IBM Watson sentiment analyzer. So this way you can see that this is our data set. For example, and it pisses me off more, they kill people who surrounded, hands up and all. If hands visible, you should not be fearing for your life. So this is an example where the tweet act is expression, emotion is multi. It was already annotated with the multi-level, the multi-level emotion, and that sentiment we have annotated with the IBM Watson sentiment analyzer. So, and then we developed some multitask model where there are two modalities. We have considered text and the emoji, and there are the three tasks. Tweet classification is our primary task. Emotion and sentiment are our auxiliary task. So we have considered the fully shared model, shared private model. So these are the different models that we have explored. So you can see that these are some results. So you know that we are these are some results, ablation studies. So sometimes we are only considering the sentiment analysis, sometimes only emotion recognition, sometimes sentiment and emotion together. And we have shown experimentally that when we are considering sentiment and emotion together, we are able to get the highest accuracy and the F1 score. So this is an ablation study that we have done. So we are also working on various other problem statements, like we are developing some chatbot or the virtual agent, which like sales agent with the help of the Accenture. This sales agent can sell a particular product, like it has the capability of like a sales bot. So it can particularly sell a particular product to a customer. Like suppose, for example, customer there is a e-shop. Customer is visiting the e-shop. Customer can specify the requirement regarding a particular product. Now the shopkeeper, this virtual chatbot, can search in database. If the product is available, then it can showcase the product to the customer, and the customer can simply purchase the product. Otherwise, if the product is not available, then the chatbot can try to pursue the customer to purchase some alternative product. And in the this in the persuasion process, it's not generic, or it's not generalized for all the customers. So there are different persuasion strategies. So depending on the personality of the customer, there are different persuasion strategies. Like if the customer is very much logical, there will be logical appeal. If the person is very much emotional, then there will be emotional appeal. If the person is buying something, if we know some personal attributes of the customer, then there will be some personal based appeal. So there are different types of appeal or persuasion strategies, and one of the strategies will be used by the virtual agent, and accordingly persuasion will be done. And after the persuasion, there will be negotiation. So negotiation means the negotiation on the price. So there will be a bargaining on the price. So the customer will fix a price, and it will be negotiated by the bot. So yeah, so we are developing this kind of sales bot with the help of the reinforcement learning agent. So with the help of the deep learning. So you can see, yes. Any question? So you can see this is the overall system that we have developed. So the user can specify the his or her requirement either through text or through image. Okay, so it is again multimodal. So user can specify the requirement either through text or through image, and the natural language understanding module is capable of understanding the user's image or the user's text. So the natural language understanding module, there is the intent of the slot labeling. So this intent and the slot labeling is understanding the user's intent and also extracting the relevant information from the user's utterance. That is the slots. Now there is a sentiment module also. The sentiment module is understanding the sentiment of the user. And then that after understanding the sentiment of the user, there is the image information module, which is extracting some information from the images also. Like for example, if this is the image shown by the customer, so it is extracting the information that this is the from the image, the color is the rose gold. So now all this information is given as a state to the dialogue manager. And the dialogue manager is basically, there are different components inside the dialogue manager. It is not a very simple dialogue manager. So the dialogue manager is having a discrepancy manager. So discrepancy manager checks that, well, initially the user has mentioned a goal or user has mentioned the specifications. Whether now there is some fluctuations are required in the specification or not. And there is a goal persuader. So the goal persuader will try to, the persuade it will try to persuade the user to buy some alternative product. So there will be a persuasion. So it will try to persuade the user to buy an alternative product. So like, there are different persuasion strategies. So either user, as I mentioned, that if we know that user is a good photographer, then the persuasion can be done based on the camera quality. Or if you know that the user is very logical, then maybe persuasion can be done by mentioning the rating of the phone. So there are different types of persuasion strategy applied. So that is the dialogue manager. And ultimately, basically, that so basically, that this time, and finally, that dialogue manager decides the action, and this action is translated into system response by the natural language generation module. So we also created our own data set. This is the data set statistics. Total number of dialogues are 1000, number of utterances are 8335, number of instances the knowledge base is 2695, number of slots are 18. And these are the different categories or aspects which are expressed using images, color, brand, keypad or touchpad, slide, shape. So these are the different aspects. So these are which we express in images. So we are expressing the brand using image, color using image, type using image, style using image, shape using image. So you can see that these are some results. So we have compared with different, there are different reward functions, because in the dialogue manager, it is a reinforcement learning based agent. So we have the main important component is the RL or the reward model. So there are three types of rewards. Task based reward, persona based reward, and also the sentiment based reward. So we want to complete the task, like finally the user wants to purchase a product and the agent one has to sell the product. So the task has to be completed. The second is the sentiment. So during the process, when the conversation is going on, like the person wants to buy a product, and the agent is showing the product to the customer, or the agent is trying to convince or the pursue the customer to buy some alternative product. In the conversation through, there should not be any negative sentiment, like the agent cannot make the user unhappy. So the sentiment based reward is very very important, because in the sales domain, customer satisfaction is very very important. So in the sales domain, we cannot make the user unhappy about the situation. So that is the task of the sentiment based reward. And third is the persona based reward. So when the persuasion is done, the persuasion should be done based on some personal attribute. Like as I mentioned, that if we know that some personal attributes of the customer, so those personal attributes should be used for the persuasion. Like if we know that the customer is a good photographer, during the persuasion we have to use this feature or this information for persuasion. So this persona based reward is using that information, that whether the agent using the correct persona based features for the persuasion. So accordingly, the reward signal is calculated. So there are three rewards. We did a ablation study. They have to identify the importance of each reward, and also we identify the importance of the multimodal. Like when you are giving the user the freedom of expressing using the multimodal features, or when the user is simply expressing using text, which one is more comfortable. So we compared with respect to success rate, average dialogue length, and also average reward. Yeah, and we have shown that this basically the persuasion strategy depends on the context. So when we are changing the context, there is a change in the persuasion strategy. So a person, when for a context one, maybe yes, a particular strategy is used, but for the same person, when there is a change in the context, some other strategy is basically used. So that is the thing, that now there is also a persuasion strategy classifier. So this persuasion strategy classifier is deciding about the persuasion strategy depending on the context. So this is our data set. So number of dialogues in the data set is 1031. Number of utterances is 11,602. Number of unique words is 59637. Average dialogue length is 11.25. Number of persuasion strategy is 6. So this is the data set statistics. And you know that persuasion strategies are default, persona based appeal, logical appeal, credibility appeal, emotional appeal, and the persona based appeal. And you can see that these are the comparison studies, and you know that context really helps. And there are some image identification errors, and the proposed context of personalized persuasive agent outperforms both the agents without persuasion and persuasion with fixed strategy. So now we are also working on developing some virtual doctors, where also we are incorporating the multimodality. So the idea is to develop some virtual agents which can help the doctors. You know what is happening in the big hospitals is that when a patient reports to a receptionist, the patient is having some self report. Now based on the self report, the receptionist used to guide the patient to visit a department. Now in the each department there are some junior doctors and there are some senior doctors. The junior doctor is responsible for the symptom investigation. So the junior doctor asks for some symptoms, and then the junior doctor makes a report, and this report is verified by the senior doctor, and the senior doctor basically that generates the prescription. So now when the in the symptom investigation phase, maybe the patient can also show some symptom name through images, and from the image from the image also the virtual doctor should be able to extract the symptom information. So it is again a multimodal, because in many cases the patient may not be aware of some the symptom name. So patient may also show some image of the symptoms. From the signs of the symptoms, the doctor, the virtual agent has to extract the symptom name. So that way it is multimodal, and it gives the user more freedom and the more flexibility. So basically we developed this kind of virtual doctor, and these are our research questions. Can a diagnosis assistant diagnose patients more effectively and satisfactorily? Considers patients visual descriptions in addition to text-based symptoms? Will patient self-reports via text and images be enough to diagnose them correctly? Can dialogue context help in interpreting an image that have surfaced during conversation? So this is our, our in natural language understanding module. So the natural language understanding module is having a text part and also image part. From the image part, we are extracting some image features. From the text part, we are extracting some text features, and then we are classifying them. So this is our image multimodal intent classification module. And as you know that we are having hierarchical symptom image classifier. So you know that we are first identifying the department name, and for each department there are some symptoms. So first we are identifying whether it is a ENT or eye or limb or skin, and for each department there are some specific diseases. So these are some symptoms specific to a particular symptom group. So this is the data set that we have used. So our novelty is basically this multimodal data set. So you know that the number of dialogues is 1500, number of utterances is 6936. So basically, the utterance tags is intent, symptom, image, information. Average dialogue length is 4.62. Number of intents 2. Number of diseases 90. Number of symptoms 266. Number of visual symptoms is 720. So we collected these images of the symptoms from the Google images, and then we verified those images by the doctors, and then we made some samples of the multimodal dialogues. So this is an example of a multimodal dialogue. Hi, I have been suffering from fever for a few days. Also, something happened in my mouth. Please see this. So maybe the patient is not aware of the symptom name. So the patient is simply showing the image of the symptom. So from this image, the virtual agent is extracting the information that this is a mouth ulcer. Did you recently vomit? The diagnosis assistant is asking. Yes, I vomited yesterday. So, do you have eye pain? Yes, I am feeling so. Have you observed any skin rash in your body? I am not sure, but please see this. So, yeah, from the image, it is extracting the information skin rash. So the report is the patient suffers from the following symptoms. So this report is basically generated and this report is given to the senior doctor. Now from this report, the senior doctor can easily prescribe the medicine. So this is basically the results. So you can see that we first compared, developed several symptom image classifiers, and we compared the results like simple CNN, Inception V3, plus convolutional layers. So we develop different classification results, and then we compare the results. So and also we have compared the results of different models. These are some dialogue management models, and the key findings are improvement of our unimodal baselines state of that model. So role of multimodality is helpful because when we are asking the patient that they can also express some symptoms using images, that gives the human more satisfaction. And there is a positive correlation between the diagnosis success rate and the dialogue length. And yes, dialogue context really helps in understanding the image better. So when we are incorporating the context, that helps us in understanding the image better. Yeah, so I think I should stop now. So if you have any question, please feel free to ask me.
Thank you, Professor, for the informative and wonderful talk. We have seen so many data sets today and some multimodal architectures, and it's really beautiful work. I have one question. As you have been working with text and images sometimes and other things that you have extracted and annotated data sets, when you have this multitask learning model, do you feel that some high performance computing is required, or like some academia or students when they are working, is it okay to work in some cloud environments, like free environments like Colab or Kaggle? What is your suggestion?
No. Yeah, we need some high performance computing, some high performance GPU servers, because image processing and also text processing. These are high. We have huge amount of feature vectors, so we really need some high performance computing. Yes. So we need a good amount of storage and also the GPU server.
When compared to the last data set where you have images and the other ones where you have majorly data along with some annotated things, do you suggest any specific data fusion strategy out of the ones that you have suggested in the beginning of the talk?
Yeah, so mostly we are, in our most of the works, we are using this early fusion. So whatever in our most of the works that we are doing in IIT Patna, we are doing this early fusion. So we are extracting the features from the images or the text or the audios and the videos, and then we are fusing all these vectors together. So and we are putting some attentions also. So till now we have not explored much the late fusion techniques. We are mostly working on the early fusion, but in the early fusion we are also exploring the attention mechanisms, because not the entire part of a feature vector is important. So as I mentioned, that based on the image we are putting emphasis on a part of the text, or based on the audio we are putting emphasis on a part of the image. So like that, attention is everywhere. So we are applying the attention based fusion, but it's mostly early fusion.
Thank you.
Ma'am,
Thank you.
I have one question. I'm just working with the transformers, and it's a spatio-temporal transformer. So if I just want to add another modality into this transformer, that is, I want to add a text. So what are the ways I can just go for another modality? I'm not actually. I just want to take a suggestion from you. I'm working on spatio-temporal transformer, so I just want to add text to it as well for some tasks. Suppose for any task. So what can do I need to just use the another feature extractor, then use the early fusion or late fusion technique like you have discussed in this
Yeah,
PPT.
so maybe what you
You are
can
not
do is
getting it.
that you can use some, like if you are using some image modality, use some CNN based feature extraction technique and have some feature vector. And now from your transformer also you will get some feature vector, and then you can add a separate some other layers. So some CNN based features coming from the image, and your this transformer specific features, and then you add some extra layers through which you pass this concatenated feature vectors. So that way you can make a multimodal system.
We have one
Ma'am.
more question from Raj.
Good evening, ma'am. I wanted to ask, like, in a single given image, if there are multiple symptoms of diseases, how is that handled?
In a okay, very good question. So you mean to say that in a single image, if there are multiple symptoms present? Okay. Yeah, very good question. So for example, for the current time being, we have not handled that. We assume that in a single image there is only one symptom present. But that is a very nice question, and that is a kind of future work for us. So for the time being, we assume that when the user patient is showing an image, so that image contains only one symptom, like that either it is a skin rash or a mouth ulcer, but you are very much
Exactly.
correct that maybe if a single image may contain multiple symptoms.
Symptoms.
Yeah, you are correct. So this kind of multi-level classification we have not done yet. Yes, that is our future scope of work. Yeah, because currently the data set that you have curated here, it is only a single level classification. So for the image only one class is present. You
Okay.
have curated like this, but very nice question.
Okay. Thank you, ma'am.
Yeah, I
Thank you.
appreciate this.
Thank you, ma'am.
Ma'am, there are some question on the chat box.
Yeah. It is a very nice question also. Yeah, ma'am, have you explored using clip for the features or constructive learning instead of using images and text modality? What would your opinion on it instead of extracting features from scratch? Also, can you explain triplet attention again? Yeah, Moti. So a clip is a very nice, clip we have not heard exactly. I have not shown in this context, but clip we are using in many other occasions. Like for example, we are also working on the hate speech detection and the cyberbully detection. So there we have used the clip embeddings. So like especially the meme. So when we are dealing with the memes, so the memes contain the text and the image. That memes are basically text and the image. So text is embodied in the image. So there we have used the clip embedding. But not here. The applications that I have shown here, and we have not used, but clip embeddings we have used in many other occasions. Yeah, and what would your opinion on it instead of extracting features from sketch? Also, can you explain triple attention again? So triple attention is basically, that because we have this three modalities for the dialogue classification. We have the video, we have the audio, and we have the text modality. So that's why we named this as the yeah, basically. But here we have done that we considered one modality fixed. So now based on the other modality, so we consider the only two feature vectors, like maybe text and only the video. Okay, now considering the video modality, we put attention on the text. Or in the next but like there are different feature vectors. You can see, if you see our model, it's a very complicated model, and there are many such vectors. And you can also see our this ACL paper, though it's now a bit old paper, but it's very interesting paper published in ACL 2020. So you can see that there are many combinations. So we have the self attention on vector on the video, then self attention on the audio, and the self attention on the text, and then we have the intermodal attention. So intermodal attention on the video and the text, then the intermodal attention on the video and the audio, and the intermodal attention on the audio and the text. So we are considering the two vectors at once, and then based on the one vector, we are putting attention on the other vector. So you can read our paper where all the mathematical details are available. So I have not put the mathematical details in my slide, because I really want to just convey the basic idea. But you can read this SCL paper, you will get the mathematical details in which are explained in detail in this particular SCL paper.
Ma'am, can you share this PPT?
PPT, yes, I will share with Rakesh. Rakesh, please share with the participants.
Sure, ma'am. We will forward this to our participants.
Yeah, and
Hello.
Tati Parthi is a question, ma'am. Can you use the multi-model techniques for dynamic data also? Yeah, it's also very nice question. That if the data is keep on changing, yeah. So that is a very good trend in social media, like for the Twitter or any kind of for the social media data. It's a kind of dynamic in nature. So yes, again we have not yet tried, but that is also a kind of very good research topic, like how you will update your model when your data is keep on changing. Like once you can build your model on a like you can follow a window based approach, so you can build your model on a window of data, and now when you are moving to the second window, maybe you need to update some of the parameters of your model. So how to do the updation? So yeah, there are many research questions, so that also we have not yet studied, but yes, so Shravanti, this is a very good research question, so you can take that up. Okay, student data, yes. Yes, Shravanti, that is a yeah. Student data also you can use. Yeah, you can use that. Yes. But always consider the ethical issues also, like whenever you are using some real life data, student data, or any kind of healthcare data, always remember the ethical issues, because on a day to like everywhere, whenever we're working on the healthcare domain, we are getting many objections from the reviewers whether we have taken care of the ethical issues or not. So yeah, ethical guidelines you need to follow whenever you are working on a very sensitive domain like healthcare, law, education. You need to follow the ethical guidelines of AI. That is also a very important, challenge. Okay, Rakesh, I think we are done because yeah, there is
Yes,
not
yes,
any
ma'am.
more
Thank you
question.
once again, ma'am, for your
Yeah,
wonderful talk.
many thanks,
So,
Rakesh, for giving me this opportunity. Yeah,
thank you, ma'am. Thank you.
many thanks, participants, for this interaction. Thank you,
Yeah,
Rakesh.
if they
Bye.